What do you know about electronics, and why do you want to get into it? Do you want to work for NASA? Do you want to build drones? Do you want to do some cool robot stuff? All those possible, and what ones are most likely, we'll see. In this video, I'm going to go through all the basics between electronics, what you can do with a degree, what you can do with an apprenticeship, what you can do along the lines, and everything you can do from electrical side and to electronics. So I myself have completed a 4-year course in electrical and electronic engineering, and from there I've learned a lot of the jobs and a lot of the skill sets that you can apply and that you can gain through these courses and through each of the steps through the process. There's a big difference between NASA engineer and hobbyist, because you can be a hobbyist very easily, but you can very rarely become a NASA builder. Electronics is definitely my favourite. There's a lot of aspects to it that come into real life scenarios. So while you're watching this on your phone, while you're playing on your tablet, while you're listening through your headphones, every single one of these devices was built by somebody in electronics. And the thing about electronics is the level at which you can go to from where you start out to where you end up can be pretty extreme. So let's get into it. If you're just starting out and you have no degrees, no qualifications, there are a few jobs you can do in electronics. Not too many granted, but there are a few. So the first one you can do is you can do a solder or a rework role. This is generally in a warehouse or a facility in which they have PCBs coming through, you need to resolder them, rewire them. It's generally, there's a small fault, you can fix it through manual soldering, but that is leading to it be outsourced to a person. So long as you work on your soldering skills, you can apply for these roles and potentially get them without a degree or without any experience at all. But in the meantime, if you do want these roles, you should be buying yourself a solder and start practicing as soon as you can. Another role you can do with no experience is an equipment fixer. So this is somebody who fixes Xbox controllers, remotes, phones, laptops. All of the above can be fixed by taking it apart, putting it back together again, resoldering certain parts, or desoldering certain parts and adding new parts to them perhaps. There's a few things that are quite simple to do, such as Xbox controllers, and then even if you want to get further into that side of things, you can then go into Xbox consoles themselves and fix the consoles, which is significantly more difficult than just fixing the controller. But these also come with their caveats of skill level. So once you kind of fixed one, you know what you're doing, and then you fix a few more, you kind of get used to it, then you can kind of keep going, keep becoming faster, and that's where it really becomes profitable, because the faster you can do it and the more you can do it, that's where your skills lie, and that's where you can create a business or you can do your own thing within electronics. And it mainly is for like side hustle potential. It's unlikely to become your full-time career, but if you really go full deep dive into it, you can definitely make it your career. And the last thing you can do to earn a wee bit of money without any experience is to enter competitions and to enter online tournaments. So these are competitions for electronics, and there's certain ones where if you design a certain build, if you design something with a theme that wins across the board, then you can learn first, second, third, or even like 10th place, getting a prize in most of them. But in general, if you want to be winning those first, second, and third places, you need to spend a lot of time in these competitions, because the competition is tough, especially when money is on the line. So you can get really good in it on your own. But obviously, if you go through a degree schedule, it might be easier to then lead into it. Whereas if you're just starting out on your own, it may be a slightly bit more difficult. But other than that, go for it, smash it. So let's step it up a level now. So if you're going through a college course or you're going through an apprenticeship, you can get a few more roles in electronics, which is quite cool. So the first few are to do with pat testing and electronic testing equipment. These generally require more certifications and will take you through from the apprentice route, because they do require more certifications. So you can't really get these on your own as much, but in general, if you can get an apprenticeship for them, you can become a pat testing engineer, or you can become essentially a fix-up engineer, but in industry, as opposed to fixing Xbox controllers and stuff. So maybe it's the transition from Xbox controllers and remote controls and stuff like that onto the pat testing engineer, which is more of an industry-based role, and, if you will, more employable and a career base. On that same level is another role called a PLC programmer. A PLC is a programmable logic controller, and these things are essentially in warehouses and industrial places where you can reprogram a device to do a similar role in a dusty and hardware environment. So there might be wind involved, there might be dust involved, there might be anything at all. Any sort of mechanical moving parts may also come into effect as well. So these devices require a specific type of programming, and They're very niche almost, to the point where you need a PLC engineer to fix them or to maneuver them, or they come with different set of faces, and a PLC engineer can come in and basically change the code within the device to make it perform differently depending on the task. So these are kind of roles that you could get straight from an apprenticeship or straight from a college degree, and from there work your way up within the company to become an expert PLC controller, and essentially to know many different systems and to work your way up the progress ladder. Another role you can get in from the apprenticeship level or from the low college level is a chip producer. So essentially there are these big factories that create chips for computers, for phones, for anything at all, and they come in these large silicon plates. You can be part of the industrial process for that, which is essentially a factory worker for creating high-tech tiny chips. So these tiny chips you might not even see as you're making them, but it's a pretty cool process within it. So if you're interested in chip design and chip manufacturing, that is kind of the warehouse type role you would be doing. So you'd be getting kitted up in a clean suit and trying to make sure no particles, no dust, no hair goes on top of these chips during production, because obviously that'll destroy the whole chip. So these tiny little chips are very precious and very unique. So if you're interested in chip production themselves, look into fabrication units and look into sort of that side of the industry, which you could get into given a college degree or an apprenticeship role type thing. So now let's get into the engineer level roles. These roles are basically what you need a degree for. You can get in through them through the trades, through long processes essentially. If you're 10 years in as an electrician, you can get through. But in general, if you can get a degree, that's how you can get entry into graduate roles, and these graduate roles can set you up for engineering roles, which can set you up for chartership. A chartership program is like saying, I'm an engineer and I've been backed by these people, this is what I've done, and this governing body has said, yes, I agree, this person's an engineer and they're pretty good at their job. So that's what you're kind of looking for with the chartership system. The only problem with the chartership system is it comes after many years of being an engineer before getting a degree. So you're looking at about 10 plus years if you're going from nothing to chartership, because it's a long process. With that being said though, some of these engineering level jobs are pretty cool. So they start off with like a circuit designer, circuit board designer, specifically as well a PCB designer, which creates and manufactures products for marketplace, for devices, for systems, and these PCB creators are the foundation of most electronics. Essentially, if you become an engineer to this degree, you will be making likely new stuff or recreating older stuff to make it better, smaller, more compact. And every year when new chips come out, that gives you new potential to grow and new potential to build new stuff and earn a higher wage. There are also roles in digital fast electronics. These are such roles as digital FPGAs. These are digital signals processing, in which you're working in microseconds, nanoseconds to try understand signals, understand FPGA controls. What an FPGA is a field programmable gate array. These are essentially logic gates combined onto a chip. So it's like a PCB, but much faster, much smaller, and doesn't take much to run. So the point of the FPGA is to build something that's small, fast, and very, very efficient. This is also a small ceiling, so you can start off small, then work your way up, and eventually you'll get to a point where you're great at FPGAs, and you'll keep learning through the process. But in general, FPGA is a potential route to go down, as well as digital high-speed processing, which I quickly ran over. It's essentially taking in incoming signals, learning what you can understand from that data, and transferring it onto another system. So if you're passing that data over to a controller, a device, anything as such like that. It's hard to talk about how many electronics roles you can do with a degree, but there is a lot of them. So in general, you're looking at around circuit design, PCB design, and FPGA design maybe, and some signal processing. These are the main kind of broad categories you can filter into, and then from there you can work on space stuff, robot stuff, drone stuff, all the cool stuff that you might think of. That's kind of how you get into all the cool stuff. And if you want to work on that on a professional level, but you can always work from it on a hobby level in your own time. One thing that nobody really tells you about electronics is it's quite difficult. It's very difficult, in fact. You're going to learn about old components that aren't relevant anymore, but you need to know about the old components in order to know about the new components, and in order to understand how circuits work in general, and just electronics as a whole. You need to understand how that works through learning the old stuff before you get to know the new stuff. And when you're trying to learn all this, none of it really makes sense, because to me, you can't see it. Like, you cannot physically see it in front of you. You have to use it or to interpret it. And what I mean by this is, until you're physically building a circuit, it probably won't make sense what it's doing, or at least that's the case in my sense. So when it came to learning about transistors, BGTs or FETs, no idea until I used them. So it's all well and good learning the practical circuits, but then you need to know. So you may be wondering, how do Arduinos fit into this? Because Arduinos are the kind of thing that hobbyists use, and it's an early gateway into electronics, but you would never see them out in professional use, in professional environments. And that's just a simple matter of fact, because Arduinos are very inefficient and very heavy space taking up vehicles. So these devices are intended for you to learn how to do electronics. So they're intended for you to learn about microcontrollers. They're intended for you to learn input and output devices, and to connect all your parts and all your components to these devices. Once you've learned the basics, so once you've learned Arduino, you can then go on to start removing the Arduino. So what I mean by that is, you can then build a specific PCB around a chip of a microcontroller, instead of getting the PCB inside the Arduino. So the Arduino itself is a PCB, which you then connect wires to. You can connect wires to a PCB of your own without having to have physical wires. Instead of physical wires, you can have copper tracks which lead off to input and output devices as you would your Arduino, but you don't need the Arduino anymore. You can make it much more efficient, you can make it much smaller, and that's the reason why you drop the Arduino and create a PCB of your own, which is much smaller, much better, and can fit into many different places. And that's where you learn the whole base of electronics from. You start with an Arduino, then you take away the Arduino, and that's how they fit into this equation. But yeah, that's a quick overview on all the electronics roles and positioning you can do throughout your electronics journey. There is potential for a full video just on degree role electronics, which could be another venture in the future, but for now we'll sign it off there. The final part in comments is, don't be discouraged, because it's a very fun activity. It's a very fun course. You can literally build robots and build cool stuff from it. So there is a big learning curve and a big jump, but once you get past the steepest learning curve, it's not crazy from there, but you will need to keep learning forever. But that should be your main goal, or that should be part of your main goal, because if you ever want to create awesome stuff, that's what you need to do. You need to keep going, keep learning, and keep pressing forward. And yeah, that's been me. So I'm Jordan. I've set up Electronics Unlocked to help people. And if you're wanting some one-to-one coaching, please go to the website, follow through the steps, and get in touch with me. And I'll be sure to get in touch with you as soon as I can. But in the meantime, like, subscribe, comment, and I'll try to reply to every single comment. And in the meantime, good luck out there. And I hope this video was very helpful and insightful towards electronics.